Welcome back to Miss Eddie's Math Movies, where it's a cute to be a square. Today's lesson is 5.5, using congruent triangles. By the end of the lesson, you will be able to show how corresponding parts of congruent triangles are congruent. What we're doing today is just going one step further. Previously, we've had congruent triangles. Now we're going to have the corresponding parts of those congruent triangles being congruent. And the abbreviation for this is CPCTC. Corresponding parts of congruent triangles are congruent. CPCTC. All right, so this is what we've been doing before. This is old that we've been learning. We're going to go one step further because we've been showing that triangles are congruent. Now we're going to go one step further and show that the rest of the parts are congruent. All right, so let's mark our picture here. In the diagram, AB and CD bisect each other. So if you remember, bisect means they cut in half. They cut each other in half. So if AB is getting cut in half, this side is equal to this side. And if DC is getting cut in half, this side is congruent to this side. So now, why are these triangles congruent? Well, I've got two sides, but I need something else. And hopefully you remember we have vertical angles. Always got to mark your vertical angles. So these two triangles are congruent by side, angle, side. So this triangle here is identical to this triangle here. Well, if that's true, doesn't that mean that angle A has to equal angle B because it's part of the congruent triangles? It's a corresponding part. So we do everything we've done before, and then we add on one additional line and reason. All right, so we have to show that ADM is congruent to BCM. And once we prove these triangles are equal, we know all the rest of the parts are equal. All right. So that was given. MA is equal to MB because of the bisector. Angle AMD, that's this angle, is equal to this angle because they're vertical angles. That's your vertical angle theorem. I abbreviate that as that. Then how do we know that MD is congruent to MC? Well, it also got cut in half by the bisector. That's the definition of segment bisector. That's how I know those pieces were equal. So look, I talked about a side here, I talked about an angle here, and I talked about a side here. And like we said, ADM is congruent to BCM because of side, angle, side. So we've done that before, but now we're going one step further, and we're proving that angle A is congruent to angle B. Well, why? Because it's part of the congruent triangle. Remember, the last line of your proof is always what you're trying to prove. So this right here, this is CPCTC. That's our reason. CPCTC, corresponding parts of congruent triangles are congruent. All right, another important part is to be able to redraw the overlapping triangles separately. So I'm going to have, here's a red triangle, and here's a green triangle. And we are going to redraw them separately, mark all the congruent sides and angles, and then tell why they're congruent. What postulator theorem? Remember, our choices are SSS, SAS, angle, side, angle, angle, side, and HL. Those are our choices. All right, so here we go. Let's redraw these triangles. Here's the red triangle, and that's JGH. And it looks like angle J has 2 arcs, and angle H has 1. Now let's redraw the green triangle. KHG. Angle K has 2 arcs, and angle G has 1 arc. So far, I see 2 angles that are the same. We have this, what else do they have in common? Look for shared sides or shared angles. Look where the green and the red overlap. The green and the red both overlap here at GH. Notice this red triangle has GH, and this green triangle has GH. And I would say that GH has to equal GH. That's called the reflexive property. So here's my side that I have. We found that both of them have GH in common. So how do we know these triangles are congruent? Angle, angle, side. All right. Now you have to redraw each diagram so the triangles do not overlap. Label the vertices and mark any congruent sides. So redraw, label, and mark, just like I did above. So you're going to do this now. I'll give you some hints. So here's the red triangle. And here is the green triangle. And you're going to redraw those and put letters with them. And then mark what they have in common. Here is the red triangle. Here is the green triangle. Go ahead and redraw those and mark them up. Alrighty. In the diagram, CB is congruent to CE. Let's mark that. CB is congruent to CE. And angle DEC, that's this angle right here, is congruent to angle ABC. We need to prove that this side is equal to this side. Well, whenever you have a picture like this, it's always helpful to redraw the triangle separately. But it says which triangles you need to prove are congruent in order to prove AB is congruent to DE. Well, what triangles are these part of? AB is part of this triangle. Alright, so here's one triangle. That's what AB is part of. And then here's the other triangle that DE is part of. So we need to use triangle DEC, and we need to use triangle ABC. A, B, C, and D. See, that's our green and our red. So let's redraw those. So here's the green triangle, A, C, B, and here's the red triangle. D, E, C. So let's mark our picture again with what we know. We know that CB is equal to CE, CB, CE. So I'm just kind of going back to this. And then let's see, we had a mark on angle E, and we had a mark on angle B. They're overlapping. Look in this picture. Look where they're overlapping. They both have angle C. I'll try to focus that more for you. they both overlap here at angle C. So I would have to say that angle C is equal to angle C. They're sharing it. That's your reflexive property. Anytime they're sharing, that's reflexive. So now let's prove these two triangles are, how do we know these triangles are congruent? Well, let's see. It looks like I've got angle, side, angle. So let's write all these things down, how we know. So we need to talk about the angle, the side, and the angle. Well, one angle was given to us. Let's write that down. So there's one angle that we've talked about. Oh, a side was given to us. So there's our side. Now we need to talk about our other angle. Well, that's the one that they're sharing. Angle C is congruent to angle C. Angle C here is the same as angle C there. We used angle, side, angle. Now, how do we know? This is what we're trying to prove. We're trying to prove that AB is congruent to DE. Well, AB is part of this triangle, and DE is part of this triangle. It's a corresponding part of a congruent triangle. So anytime you see that it's part of a congruent triangle, look, it's part of that congruent triangle. It's part of that congruent triangle. That's when we use CPCTC, right after our triangles. Always comes after. All right, you need to redraw the triangle separately, label all the congruent parts, and then show that the triangles or corresponding parts are congruent. Okay, so here is the red triangle. Here is the green triangle. Redraw those and label, and then mark your picture. Mark your picture with this. And let's see if we can figure out why these triangles are congruent. So it's really important that you redraw those. So here I want you to redraw. Here's your green triangle. Here's your red triangle. So redraw those and then mark your picture. And see if you can figure out why the triangles are congruent. These are your reasons. You're going to have to find one of these. Right, your reason for this is going to be CPCTC, but you have to find the triangles first. So, get those done now. This is M Cubed signing out.